Alright, so we're going to look at some of the practice problems from the section titled Radians on the Unit Circle in Khan Academy. So here's a typical problem that'll come up. It will give us a picture of an arc. So we've got this arc swept out here that is 2 pi over 3 radians in standard position. So standard position means we're starting right here, sweeping 2 pi over 3 radians to here, stopping, and there's our arc. There, so I've got it nice and bolded in red. So first let's figure out what is the measure of the arc in degrees. So if we want to convert 2 pi over 3 radians to degrees, we're going to multiply by our conversion factor, which is 180 over pi. So when you want to convert radians to degrees, you take your radian measurement and you multiply by 180 over pi. Now I just need to simplify here. These pi's would cancel. And then oftentimes when I'm doing this without a calculator, I find it easier to do the division first here. So I could multiply 180 by 2 and then divide that by 3. But I think it'll be easier here to divide the 180 by 3 first to give me 60 and then multiply that by 2 to give me 120 degrees. Another way you could have thought about this is that, you know that pi radians equals 180 degrees. That's sort of our definition for converting from radians to degrees. So that means that, well, if I divided both sides of this equation by 3, that would tell me that pi over 3 radians is 60 degrees. So if I know that pi over 3 radians is 60 degrees, and over here I have 2 pi over 3 radians, that's just going to be 2 times 60, which is 120 degrees. So you could use some proportional reasoning to figure that out. Now here's another typical question that'll come up. What proportion of the circle does the arc occupy? So to figure that out, we're just going to take the measure of the arc, 120 degrees, and divide that by the measure of the entire circle, which would be 360 degrees, which would be a third. So that arc occupies a third of the circle, which makes sense because just by looking at the picture, that looks like it's about a third of the entire circle. Could have also done this computation by using the radian measurement. So if we have that the arc is 2 pi over 3 radians, we could divide that by the number of radians in one lap around the circle, which is 2 pi radians. And I could simplify that by taking the numerator 2 pi over 3 and multiplying it by the reciprocal of the denominator, which would be 1 over 2 pi. And then if I simplify here, these pi's cancel, and so do the 2's, and we wind up with a third. So, which is the same answer that we would get if we're measuring in degrees. Obviously, it has to be a third of the circle both ways, whether we're measuring in radians or degrees. So, other questions that might come up here, maybe we would be asked, what's the sine, cosine, or tangent of 2 pi over 3? So I'm just going to grab my eraser here really fast. So how would we do that? Well, if we had our unit circle, we could just look at this point right here, and that point is going to be negative 1/2, comma, root 3 over 2. So then we would know that the sine of 2 pi over 3 would be root 3 over 2, and the cosine of 2 pi over 3 would be negative 1/2, because the cosine is the x value of the points on the unit circle, the sine of the angle is the y value of the point on the unit circle, and for the tangent of 2 pi over 3, that's just going to be the y value over the x value, so root 3 over negative 1, or negative root 3. Now, if we didn't have the unit circle handy, or like if we didn't have the unit circle memorized, we were doing this on a test or something like that, and we did not want to use sort of the unit circle approach, we could just draw a triangle in here. We could just drop down this right here and label the sides of our triangle. So if this angle is 120 degrees, That means this must be 60, because the 120 plus 60 has to make 180, which means we have a 30, 60, 90 triangle. And then we can just label we can pick any sides of a 30, 60, 90 triangle that we want here. So maybe we'll call this root 3, and this -1, because it's going to the left. Root 3 is positive because it's going up. Call this hypotenuse 2. So then the sine, look at that, root 3 over 2. The cosine, -1/2. The tangent, root 3 over -1. Now I know that for the unit circle, the sides I picked, like this 30, 60, 90 triangle wouldn't actually fit in the unit circle here, because really like this radius is 1 for the unit circle. But when you're evaluating the sine, the cosine, or the tangent, and you have a 30, 60, 90 triangle, you can sort of pick any sides for a valid 30, 60, 90 triangle that you want, because the sine of 60 degrees here, or the sine of 120, is always going to be root 3 over 2. So, I mean, if I wanted to make this totally true to the unit circle, I could just divide all my sides by 2. Like the hypotenuse would then be 1. This would be root 3 over 2. This would be -1/2. I would get the same ratio values. So other questions that come up, sometimes they give you pictures like this, and they ask you to find the measure of the angles. So this is a really big arc. So let's think about this. From here all the way around to here, that'd be 180 degrees. But then we also have this piece right here, and this piece right here to make the whole arc. So it looks like this slice is going to be, I believe, 30 degrees, because that's a third of the way from the 9 to the 6 here. Like this looks like it's 90 degrees. So from right here, that chunk is about 30. So it looks like this angle is 180 plus another 30 plus another 30. So that would be 180, I'll write that out, plus 30 is going to be 240 degrees. And if we wanted to do that in radians, remember to measure, or to convert from degrees to radians, you multiply by pi over 180. And then we just reduce the 240 over 180. I'll do that down here. So I could divide both by 10. I would get 24 over 18, and then 24 and 18 are both divisible by 6. So that's 4/3. So 240 pi over 180 is 4 pi over 3. So questions like that are very common. And as are questions like this, where we are given an angle and we're asked what quadrant does that angle live in. So just thinking of the unit circle here, we've got 0 degrees right here, 90 degrees is right here, and 90 degrees is pi over 2 radians. Pi radians is 180 degrees. 3 pi over 2 radians is 270 degrees. And then back around 360 is coterminal with 0. So 7 pi over 6, 7/6 is a little bit bigger than 1. So this angle is going to be a little bit bigger than 1 pi radian. So that'll probably put me right about there. Like the angle is going to be a little bit bigger than pi radian. So that's the answer is probably quadrant 3 sounds good. So if we wanted to do this in degrees and just really be sure, well, actually we can be totally sure here, because 7/6 is definitely less than 3/2. 7/6 is definitely less than 1.5. So we're definitely right with the quadrant 3. Remember, the quadrants go 1, 2, 3, and 4. You could convert this to degrees if that makes you more comfortable. So we could multiply this by 180 over pi. Reduce, cancel the pi's. 180 over 6 is 30, and 30 times 7 is 210. So that's just 30 degrees more than 180. So it's definitely in quadrant 3.